distributed ledger, right? Which has all let's say I have some Bitcoin, I send you some Bitcoin, you send him some Bitcoin. All these transactions get stored on the blockchain let's say you call it a database, right? And each block has transaction, and it's like a chain of blocks, right? That blockchain is saved on every single person running a Bitcoin node. So like millions of nodes all over the world have a copy of the blockchain, right? So some advantages of the blockchain is that it's immutable. It can't be changed because there's so many copies. If you change one, you have to do 51% in order to change one. That's pretty much impossible for blockchains that are as vast as Bitcoin and some of the higher ones. And it's also transparent. Anyone can see the blockchain. Everyone can read, can see all the transactions on there. So there's that, and so there's many advantages of the blockchain, right? And that's Bitcoin. Anyone know about Ethereum? I mean, you guys all right. So Ethereum is similar. It has a blockchain, but in addition to all the transactions, it has like a snippet of executable code called a smart contract. So it has the transactions on the blockchain. It also has all these smart contracts on the blockchain too, and those smart contracts are compiled on the Ethereum virtual machine, and they're saved on every single blockchain that runs Ethereum, right? Every Ethereum blockchain, all the nodes, right? So when smart contracts came out, I mean, but there's many uses for it. Pretty much, it's like, how many developers are in the crowd? Anyone know about object-oriented programming? Okay, all right, cool. So with smart contracts, it's called contract-oriented programming. And a smart contract looks very similar to a class, where you create objects with. So you can do anything, with classes. And so the use cases for smart contracts is limitless. It doesn't have to be for, real estate deals. It could be for anything. I mean, it doesn't have to be for contracts. It could be for any kind of application. So here at Zap, we are envisioning a future of dApp development. Like, I would say the future of blockchain technology is, and what dApps are, decentralized applications. Pretty much applications that are utilizing the blockchain. And I guess the backbone of those dApps are smart contracts. That's the part of the application where you use the advantage of the immutability and the transparency and all the advantages of the blockchain, right? So the problem with smart contracts is smart contracts can only communicate within the Ethereum network. They can only communicate with other smart contracts. In order to get off-chain data, like outside data, let's say, for example, crypto prices. Let's say you're creating a dApp for crypto prices, right? And you want to, let's say you're creating a dApp for like futures, derivatives, and when Bitcoin hits a certain amount, like let's say X, then you sell, let's just say, right? Now to get that data, you need to get, that's off-chain data. That's not within the Ethereum network. So in order to get that off-chain data, that data needs to be has to be oracleized, pretty much. And pretty much what an oracle is, it's the bridge between the smart contract and the outside world. So, whether it's crypto prices or the weather data or any kind of application, any kind of data that's off the blockchain, in order for it to communicate with a smart contract, it needs to be oracleized. And many of the smart contract developers know eventually, when you do smart contract development, you're like, I need oracles. You're going to find out you're going to need oracles. So that's where Zap comes in. We are facilitating the development of oracles we just released our SDK last month, and with our SDK, you can create oracles seamlessly, as well as you can monetize off those oracles. Pretty much, you can sell the data, the oracle data, to a smart contract developer.